Really?
Seriously?
That happened, right?
Is my clicking going to be okay?
Right then. Probably. All right, here we go. Okay then, welcome back. We're at Unit 4-1. Today we're going to be simplifying rational expressions. Simplify. You know what simplify means? Just make something as small as possible. Rational expressions just means that the things we'll be looking at look like fractions. You're going to have a numerator and a denominator, and there'll be some algebra mixed in there. Let's take a quick look at our math career for today. An inventory control specialist. This is for all you organizers out there, people who like to organize and list and know where things are. These people maintain the perpetual master inventory listings of all property, coordinates the annual inventories of all property and equipment, and warehouses or disposes of surplus property owned by an agency. You can see the salaries down there on the bottom left, and you can see your math requirements there if you want to look into something like this. But really good for those that like things in order and can manage a lot of things at once. Alright then, if there's a career that you have an interest in learning about, leave me a note with your email address and I'll forward you the information. So if you see something along the year, something you want to know more about, just let me know. Alright, real quick, at the beginning of the unit, I'll just have a reminder of what's expected. Remember that the number one thing is limit your distractions. Okay, I know you've got some other things going on right now, but this is about a 10-minute video. Go ahead and try to give it that 10 minutes there real quick, and you'll get a lot of benefit from it. Occasionally, you'll need to write some information down. You'll see this right here with a paper and pencil. There will be some practice problems that we'll ask you to put. If you see the guy with the chalkboard, go ahead and jot those in your notebook for sure. And at the end of every lesson, just give us one question, something that you can ask about in class next time we see each other. All right. So again, if you see these, this is a watch only. This guy here, there'll be one of those in here at least. And then again, the practice stuff there. All right, we're in standard 12.0. And here's what we'll be doing. Today we will simplify rational expressions and state exclusions. We'll talk about what an excluded value is pretty soon. Here's your vocabulary. A rational expression. This is an algebraic expression whose numerator and denominator are polynomials. Remember, polynomials are fractional or algebraic expressions that have more than one term. And an excluded value. This is any value that makes the denominator equal to 0. You know from a long time ago that you can't divide by 0. We'll actually look and give a reason for that today for you. Alright, the rational expression is in its simplest form when the numerator and the denominator have no common factors except for 1. So in other words, you're going to take a fraction or a rational expression and reduce it to where you only have a common factor of 1. So let me ask, is the following in simplified form? 2/5. So take that rational expression, or otherwise known as a fraction. Can we reduce that? And the answer is no. 2/5 is reduced. Their greatest common factor is 1. How about 2/6 though? 2/6. Well, this here, of course, has a common factor of 2. So this is not reduced or not simplified. 7/28. This can be reduced. They both have a common factor of 7. That's something other than 1. How about 2x/5? Well, I see an x and a 2 in the numerator and a 5 by itself in the denominator, so no, we can't reduce that. But what about 2x/5x? Do you see that the numerator and the denominator contain an x, so we could reduce this down to simply 2/5. Alright, here's a watch only for you. Let's take a look at our first example here. 5n cubed over 10n. 5n cubed over 10n. So the first thing you might want to do is look at it kind of in a broken up way. So 5n cubed over 5 times 2 times n to the first. What do you see can quickly be reduced here? Well, it looks like the 5's can be simplified and reduced down to 1. N to the third over 2n squared. Well, how about the n's? We could take 1n from here, 1n from there, and our final result is, in the numerator is n squared, and the denominator is 2. So you're looking at n squared over 2. Okay, how about this one? Let's go ahead and add this one to your notes here. Let's see, 2r to the 4th over 14r. So take a look at that for a second. Jot this guy down. They both 2 and 14. Those are both even numbers. So what can we divide out of every even set of numbers? We can take a 2 out. And do you see an r in the numerator and denominator? So if we break this up, we end up with 2r to the fourth over 2 times 7r to the first. Maybe the 2's cancel, and maybe some r's, right? So the 2's are going to cancel. And how about one of the r's here? And we end up with r to the third in the numerator and simply a 7 in the denominator. And if you look here, r to the third over 7, well, that can't be reduced. Their greatest common factor is indeed just 1. All right, here's something we call the wedding rule. If two terms are connected or married by a plus or a minus, you cannot cancel one term without canceling them both. Okay, so the wedding rule treats like two terms become one expression that you have to work with. Like a husband and wife, two separate people get married, they become one family unit. So if n equals 6, let's look at an example here. N plus 4 over 2. N plus 4 over 2. Well, we know if n equals 6, then we've got 6 plus 4 over 2, and we get the correct answer of 10 over 2, which is 5. Okay. Now, what if we decided we'll try to be clever here, 6 plus 4 over 2, and we wanted to divide a 2 out? Well, 4 and 2 look like they work nicely together. Divide the 2 out of both, and now we end up with 6 plus 2 over 1, which is 8, and of course this is incorrect. Okay, this would be incorrect. We've got to deal with these two together. The 6 plus 2 would be incorrect. We want to stick with the 6 plus 4, add that up, and then we would divide by 2. In other words, make sure you follow order of operations, especially when you're dealing with integers. Okay, how about this? N plus 4 over 2. And if we wanted to ask about reducing that, well, there's really nothing we can do here. This cannot be simplified any further. It's still n plus 4 over 2. So that's our final result right there. Because notice, even though these two want to reduce, we have to deal with these as a unit. So because 2 can't go into n, we don't know what n is, then we have to just leave it as n plus 4 over 2. All right, here's another watch only. 10x squared plus 5x over 2x plus 1. So what are we going to do first here? Well, how about we factor out something out of the top, like a 5x. And lo and behold, what do you see here? 2x plus 1 in this quantity, 2x plus 1 in the denominator. So what can be reduced? Well, the 2x plus 1s. So you're left with simply your answer of 5x. Here it says that couples cancel. That's correct. 2x plus 1 and 2x plus 1. Just treat them like a couple. They match perfectly. They cancel out, and you're left with 5x as a result. All right. Here's a practice problem for you. So try to simplify the following here on your own. 6n squared plus 3n over 2n plus 1. So look back at the previous problem. What did we do? We factored something out of the top, and then we reduced. So give that a try for a second. Now's a good chance you can exercise your power. Pause the video, try it out, and see what happens. All right then, let's assume you went ahead and practiced that real quick. So did you factor out a 3n? Well, if you factor a 3n out of both terms there, you'll notice that you have 2n plus 1 and a 2n plus 1 in the denominator. Of course, these both cancel out, don't they? So you're left with simply 3n. Okay, well done. Hope you got 3n. Now, how about this one? X plus 2 over x squared plus 5x plus 6. So where do we begin with this? Don't see, before we're dealing with binomials, now I've got this little trinomial in the denominator. Well, do you recall that this looks like an easy x down here at the bottom? So x squared plus 5x plus 6, take what you learned from before. Give me two numbers that add to 5 but multiply to positive 6. What are we looking at there? How about x plus 2 times x plus 3? And if you don't kind of remember that, go back, look at your easy x examples, do your x, drop something in the top, something in the bottom, and this is what you'll end up with. Now, of course, what cancels top and bottom here? X plus 2's do. So you're looking at 1 over x plus 3. These couples here cancel out. Don't forget, the numerator can never be empty. The least it has in there is a 1. Okay? So your answer is 1 over x plus 3. All right, now let's move on to our last piece here, excluded values. Now, an excluded value simply says something that will make the denominator 0. So an excluded value is similar to an extraneous solution. We may use that term a lot as well. It is an answer that cannot be allowed due to a conflict of logic. So let's follow this. Answer the following. What's 5 plus 0? Well, we know that's 5. What's 5 minus 0? Again, That's just 5. What's 5 times 0? We know that to be 0. Okay. Well, what about 5 divided by 0? So either way you write this, 5 divided by 0 in this linear fashion or kind of like a fraction, we end up with dividing by 0. So what's going to happen here? So watch this. Why can't we divide by 0? So let me give you one example to kind of bring out the point here. So watch this. 10 over 5. Well, now we know that answer is 2. 5 goes into 10 twice, but let's prove it using our math logic. So we know that 10 over 5 equals 2, and we can prove that by taking the denominator here and multiplying it by the quotient. 5 times 2 is 10. So we know that 10 equals 5 times 2. True or false? Of course, that's true. All right, now, therefore, if we follow the same steps, what's 10 divided by 0? Well, let's honestly say we don't know. Instead of putting a 2 there or something made up, we'll just put a question mark. We don't know what that is. Now, what did we do here? Here we multiplied 5 times 2, and we got the number 10. So let's do the same thing. Is it true that 0 times this question mark is going to equal 10? Well, we know that 0 times anything is 0. So that is stating now that 10 equals 0, and that's not true. Since we can see that 0 times the question mark, whatever that happens to be, cannot be anything but 0, we can't have a statement of dividing by 0, because this would give us a false multiplication. This would say something times 0 is 10, and we know that's not true. All right, so there's a little bit of why we can't divide by 0. There's another way to look at it, dealing with infinite values and so on, but maybe we'll talk about that later. All right, 7 over 6 minus y. Now, we cannot have this denominator equaling 0. So what value for y would make the denominator 0? So let's see, if you put a 0 here, 6 minus 0, that'd be 6. That's okay. What if you put a 1 there? 6 minus 1 would be 5. That's okay also. What value here would make this whole piece at the bottom 0? Well, in this case, what we have to talk about is something that's called undefined, where we don't want to make the expression undefined. So what value for y will make the expression undefined? So of course we can't allow y to be 6, because 6 minus 6 is what number? 0. There we'd end up with 7 over 0. So we're going to talk here about not allowing something in the denominator to allow the expression to come up with an answer of 0. So if y were 6, the denominator would be 0. Since division by 0 is not possible, y cannot equal 6. It can be anything else, just not 6. All right, your turn. Name the excluded value for each rational expression. So again, what would make this 0? How about negative 6, right? Negative 6 plus 6? So we can't allow y to be negative 6. How about this one? 12 over m minus 3. What do you think? What can we not allow m to be? Well, m can't be 3, because what's 3 minus 3? 0. Can't have that. How about this one? 12 over 7 minus n. Well, what do we put in there for n to make that 0? We'd say 7, so not good. So n can't be 7. And how about this one? 12 over 2n minus 1. A little tougher here. What's going to make this 0, this whole piece at the bottom? Well, if we need to, we can do the following. We can set this up. If you're not sure where to go from here, then what we could do is we could take 2n minus 1 and set it equal to 0. And whatever this is our excluded value. So how about 2n equals 1? Divide both sides by 2. You saw I just added 1 there, right? So n cannot equal 1/2. If you put a 1/2 here, doesn't that make sense? Half of 2 is 1, and isn't 1 minus 1 equal to 0? So that's no good there, okay? So we can't have, clear that, we can't have n being 1/2. Right there. All right then. How about this? Pretty simple there. N can't be what number? 0. Good. All right, and that's it for Unit 4-1. If you'd like more instruction, you can navigate to thinkcentral.com, type in this code in the search box, exactly as you see it there, and you can watch video example 1 or 2. Make sure you have a question for us. You may be called upon, or you can ask voluntarily. We'll see what happens. All right then. I'll talk to you soon.